Question 7 is an investigation question. The investigation is surrounding a experiment between zinc and sulfuric acid. And two experiments are done. The first experiment reacts chunks of zinc, and the second experiment uses zinc powder. So the independent variable that changes between the two is the surface area, or the state of division of the zinc, and what we're measuring is the rate of reaction. So in terms of a hypothesis, it would be sensible to suggest that experiment 2 would have a faster rate, because that's the one where we're using powdered zinc. And then you're asked to justify your hypothesis, and the justification would be that the powdered zinc would have a much greater surface area. Now you'd need to put these into coherent sentences, obviously. Greater surface area, and that means that there would be more collisions per unit time, and that would result in a increase in the rate of successful, just going to abbreviate, collisions. So to recap, our hypothesis would be that experiment 2 would have a faster rate, and the justification is that in experiment 2, powdered zinc has a greater surface area, and therefore there are more collisions per unit time, and hence the rate of successful collisions increases. State the independent variable. In a sense, we've already done that. The key here is the difference between chunks of metal, chunks of zinc and powdered zinc, and so the independent variable would be the surface area of the metal, the zinc, or you could call it the state of division. Balanced chemical equation for the reaction. It's a reaction between zinc and solid state reacting with sulfuric acid, H2SO4, which is aqueous, and an acid plus a metal gives you a salt. In this case it's zinc sulfate plus hydrogen gas, H2 gas. You'll know that zinc is in group 2, so it will form a 2+ ion. The sulfate ion, SO4, is a 2- ion, so the formula of zinc sulfate is just ZnSO4. Just quickly check the balancing: 1 Zn on the left, 1 on the right, 2 H's, SO4 and SO4. So it's balanced as it stands. Reason why excess sulfuric acid is used. The key here is to understand that the amount of sulfuric acid that's used in this experiment is a variable that would affect the rate of reaction. And so, because we're not studying that variable as our independent variable, we need to control it. And by making it in excess, in other words, using more than we need, that then controls the variable between experiment 1 and experiment 2. So an excess of sulfuric acid is used to control the amount of acid as one of the variables. 7.5 asks us to calculate the average rate between the 20th and the 40th second. There's a 20th and the 40th second. So what they're asking is for the gradient of the straight line between those 2 points. So gradient is change in y, change there, over the change in x, which is the change there. And so if we calculate that quickly, rate is change in y will be 15 minus 10. Change in x is 40 minus 20, and that gives us 5 over 20, which is 0.25. The units are given in the question, so make sure you get them correct. Centimeters cubed per second. (7.6) asks how the average rate of experiment 2 will compare to that of experiment 1. The graph is shown for experiment 1. In experiment 2, the zinc is in powdered form, so we'd expect a faster rate of reaction. So the graph would be steeper at this point, but it would end up at the same place. And so if we consider the gradient between the 20th and the 40th second, you'll see that it's steeper than the gradient for the experiment 2 is steeper than for experiment 1. And so the average rate will simply be greater because we're using powdered zinc. (7.2) then asks the question how the total volume of gas compared to that of experiment 2. If we go back to that previous slide, you'll see that I've drawn the graph so that it finishes off at the same point. In other words, the same total volume of gas is formed. And the reason for that is that we have the same amount of reactants, and therefore we'd expect the same amount of products. So it would be equal to, and your justification would be that we have the same amount of reactants, and therefore we would expect to get the same volume of product being formed. And so the total volume of gas would be equal in both experiment 1 and experiment 2. 7.8 then asks for 2 ways in which experiment 1, in which the rate could be decreased. Notice, decreased. There are a number of ways. Probably the easiest way would be to decrease the temperature of the acid. You need to be specific whose temperature you're changing. And then the other way would be to decrease the concentration of the acid. Let's be specific and say the sulfuric acid.